Bismillahirrahmanirrahim. Welcome to lecture number 5 of data science. The course code is CS325. We will continue our discussion on introduction to programming in Python. In last few lectures, we discussed theoretical concepts of data science. I told you that from the next lecture, we will discuss the hands-on exercises and we will understand how to write data science related code in Python. But since you have not studied Python before, you have studied C++, Java, and other programming languages, but Python is a new programming language for you. So few lectures we will spend in Python. We will try to understand the concepts in Python, how to write code in Python, and then we will move on how data science related concepts like data manipulation, data processing, machine learning algorithm, how these concepts can be coded in Python programming. So this is the discussion agenda. We will discuss functions, tuples, arrays, strings, array operations. So let's go to our Jupyter notebook. This is our Jupyter notebook. Yeah. So let me zoom in a little bit. Okay. So the Python programming language, we start from functions. So how do we write functions? So this is I have shown you this Jupyter notebook interface before. So this is our cell, and we have written, let's say, some code. X is equal to 1, y is equal to 2, and x plus y. If I simply press shift enter, so it prints 2 plus 1, 3. I can use the print function, print y, print x, and print x plus y. Print y will print 2, print x will print 1, and print x plus y will print 3. You see? Now, how to write functions in Python? So, for example, we have add numbers. It's a function that takes two numbers and adds them together. So, we have def, and then we have add number, a function name. We have parenthesis argument x comma y followed by a colon. This is very important. This colon is very important, and then the next line, it is indented. This is a tab. This tab is very important in Python, and we have written return x plus y. So then I can call this function add numbers, and I pass argument 1, 2, it will return 3. You see? Add numbers updated to take an optional third parameter. Using print allows printing of multiple expressions within a single cell. So we have the same function, add numbers x, y, and z. Z is none. So if z is none, we return x plus y, else we return x plus y plus z. So first we call adding two numbers, and then we call adding three numbers. This is the concept of function overloading. If you remember this from C++ or Java, so this is how function overloading, it means functions with different number of arguments are called. So for the first answer is 3, for the second answer is 6. Now add numbers updated to take an optional flag parameter. So we have x, y, z, and a flag which is default value is false. So if flag is true, then we print flag is true, and if z is none, then return x plus y, else return x plus y plus z. So we have add numbers 1, 2, flag is equal to true. So it will print flag is true, and it will print 3. Flag is true and 3. Assign function add numbers to a variable a. So we have this function add numbers, and we assign to a variable a. So add numbers A. Remember, we are giving a function a name. So then we call A 1, comma 2. It prints 3. So this is how functions are coded in Python programming language. Then we have types and sequences. So we can use type to return the object's type. For example, this is a string and we write type. So type will return string. Type none. What is the type? It's none type. Type 1 is an integer, so it will return int. Type 1.0, it's a float. Type add numbers, it's a function name. So this is how type and tuples. Tuples are an immutable data structure. Immutable means it cannot be changed. So let's say we have x and its tuple. Tuple is defined in parentheses. So we have 1a, 2b. Its type is tuple. And this is how we print. For items in x, print items. So let me do like this. So it prints for items in x. It print 1a, 2b. So this is how tuples are created and tuples are printed. Now we have list, and tuples are immutable data structure, but lists are mutable data structure. So we have 1a, 2b, and we type x, so it should print. By the way, this type was not printed because we have a print function here. So what we can do like this. You see, tuple. Now if I type here type x, so it's a list, and since it is a mutable data structure, so we can append. So I can say x dot append 3.3, and then I print x. So it's 1a, 2b, 3.3. So this is an example what we saw for tuple. So this is an example of how to loop through each item in the list. So for item in x, print item. It will go through all the elements 1a, 2b, and remember 3.3 is added later, so 3.3 is printed. Or we can use indexing operator. So for I is equal to 0, while I is not equal to length of x. Remember, length of x will be 5. 1, 2, 3, 4, 5. So while I is not equal to length of x, print xi and increment I by I plus 1. You see, it is printed 1a, 2b, 3. We can use plus operator to concatenate lists. So we have one list 1, 2, and we can add it 3 plus 4 to make it one list 1, 2, 3, 4. We can use star operator to repeat lists. So for example, if I want to repeat 1 3 times, I can do like this. We can use the in operator to check if something is inside a list. For example, 7 is not inside this list, so it will return false. And if I search for example, number 3, 3 is inside the list, so it will print true. Now, let's try to understand strings. Use bracket notation to slice a string. For example, we have, this is a string, and I say x bracket 0, it will print only the first character. If I say 0, 4, it will start from 0 up to 4, so it will print this. It will start from 5 up to 8. You see, 5 is I, and 6, 7, 8 is this one, so less than 8. This is printed. For example, this will return the last element of the string. So x minus 1, last element is g. This will return the slice starting from the fourth element from the end and stopping before the second element from the end. You see, minus 4, 2, minus 2. So minus 4 is, you see, minus 1, minus 2, minus 3, minus 4, and minus 2 is this one, Ri. This is a slice from the beginning of the string and stopping before the third element. So start from the beginning of the string up to the third element, Thi. And this is a slice starting from the third element of the string and going all the way to the end. You see, S is a string. Let's say we have two strings, Christopher, Brooks. We can print first name, plus is used for concatenation, space, last name. We can do, so let me execute this. You see, this is written Christopher Brooks. We can do first name multiply by 3. It will repeat Christopher 3 times. We can do Chris in first name. Since Chris is string is in the first name, so it returns true. Then we have a split function. Split returns a list of all the words in a string or a list split on a specific character. For example, first name, so this is a full name and we split it with spaces and we take the first element, so it will print Arthur, Christopher, Arthur. So you see, it takes the one. If I want to print Christopher, so I can do 0, Christopher. And if I do the last name, I can do the last, Brooks. You see, Brooks is printed. If I want to print the middle name, for example, so maybe I do like this. Okay, so this is how we process strings. Make sure you convert objects to string before concatenation. If I do Chris with plus 2, these are different types, and you see there is an error. Error is we cannot concatenate string with integer. So if I do like this, if I convert 2 to string, it will print Chris plus 2, Chris 2. Now we have dictionaries. Dictionaries associate keys with values. For example, we have names and we have their corresponding email. Name, colon, email. And dictionaries are enclosed in braces. So I can retrieve the email of Bill Gates. Bill Gates is a key. You see? I can add a new element and I can add its email and I can retrieve this one. Wait a minute, shift enter. Okay, because I'm executing this one, so maybe I should disable this one for a while. This one. You see, this element is added. If I want to update previously Bill Gates to a new email, it will print like this. We can iterate through all the elements in the list and you see Bill Gates email is updated. We can iterate over all the values for email in x.values and print email, so it will print all the values. Iterate over all the items in the list, so name, email. You can unpack a sequence into different variables. For example, we have this sequence and we can have first name, last name, email, X. And if I do fname, it will print the first name. If I do last name and X, so last name print the last element of the sequence, and X prints the whole sequence. Make sure the number of values you are unpacking matches the number of variables being assigned. So let's say we have X, Christopher, Brooks CH at this one, and this is another. So we can extract first name, last name, email, middle name, X. Since there are 4 values, we are unpacking 4 values. If I remove this one, like 3, it will give me an error because there are too many values to unpack, expected 3. So what I do, middle name, more unstring. So if I do print Chris plus 2, you see it's an error. So Chris plus string 2. Python has a built-in method for convenient string formatting. For example, we have this dictionary, sales record, price, this one, number of items, this, person, Chris. Sales statement, prices bought, this, items at a price of this, each for a total of this one. Now we can do this sales statement. So person Chris bought 4 items at a price of 3.24, each for a total of 12.96. And it's very convenient because we can change this one. For example, if I copy this one and I copy here and I just copy this one, so I can change the quantity. Let's say 5 with let's say 2, and let's say this is bill. So you see how I change the string formatting by using this braces. Now let's try to read and write CSV files. Let's import data file mpg.csv, which contains fuel economy data for 234 cars. So if we go through the directory, this is our directory, let me go to that. This is mpg.csv file. If I open it, so this is a spreadsheet. There are some rows and columns. It has some cars data, manufacturer, model, and some other attributes for some 234 actually. So what we do, we want to load this data in Python. So the first thing you need to do is import library CSV. We set precision to 2, this is optional, and then with open mpg.csv as CSV file, mpg is equal to list csv dot dictionary reader CSV file, and we just print the first 3 elements. You see it is loaded. First element is number 1, manufacturer Audi, model, and so on. second one, and third one. CSV dictionary reader has read in each rows and our CSV file as a dictionary. Len shows that our list is comprised of 234 dictionaries. You see? Keys give us the column names of CSV. So mpg 0.keys. This is how to find the average city fuel economy across all cars. All values in the dictionaries are string, so we need to convert to float. So sum convert to float. D is coming from this dictionary mpg. For D in mpg, divide by length of mpg. So this is the average fuel economy. Similarly, this is how to find the average of heavy fuel economy across all cars. So this is CTY, this is heavy, 23/4. We can use set to return the unique values of the number of cylinders the cars in our data sets have. So set D cylinder for D in mpg, and we print cylinders. So you see there are many cylinders. If you go to the Excel file and we go to the cylinder, you see there are many values of 4 and 6 and 8. But if we do unique values, we do this one. So we have cylinders of 4, 5, 6 and 8. Here is more complex example where we are grouping the cars by number of cylinder and finding the average city mpg for each group. So this is city mpg by cylinder. It's an empty array. For C in cylinder, it means iterate over all the cylinders level. Sum pg is equal to 0. Cylinder type count is equal to 0. For D in mpg column, if D cylinder is equal to C, then sum pg is equal to float D cty, and cylinder type count plus equal to 1, and we add this C to this array. The C means cylinder, and this is the average fuel economy, and we can sort. Key is equal to lambda. Lambda is a special type of anonymous function, and it returns x0, and we print like this. So for cylinder 4, the fuel economy is 21.01. For cylinder 5, the fuel economy is 20.50. For cylinder 6, the fuel economy is 16.22. For cylinder 8, the fuel economy is 12.57. We can use set to return the unique values for the class types in our data set. For the class, if we look to the class, this one. So our class is this one. Compact SUV, 2-seater. So we want to know how many classes we have. 2-seater, compact, mid-size, minivan, pickup, subcompact SUV. And here is an example of how to find the average heavy mpg for each class of vehicle in our data set. It's a complicated example, but heavy mpg by class. For T in vehicle class, sum mpg is equal to 0. vehicle class count is equal to 0. For D in MPG, if D class is equal to T, then sum MPG plus equal to float D heavy, V class count plus equal to 1, it means increment the count, and then we add this information into our array, and then we sort this array and we print it. So for pickup, the fuel economy is 16.88. For SUV, the fuel economy is 18.13. For minivan, the fuel economy is 22.36. For two-seater, the fuel economy is 24.80. For mid-size, the fuel economy is 27. For subcompact, the fuel economy is 28. For compact, the fuel economy is 28. So you see there are pairs. This is one pair, this is another pair, and how these pairs are added in a list. Now let's try to understand dates and time. So for date, we have date time as dt and time as tm. Time returns the current time in seconds since the epoch, and the epoch was 1st January 1970. So the number of seconds since then is these many. And you see every second you do this one, it changes. So we can convert the timestamp to date time by using dt.datetime from timestamp tm.time. So the date time now is 2021 4 8 00 16, and this one. Now let's try to understand handy date time attributes. Now date now dot year, date now dot month, date now dot day, date now dot hour, minute, and seconds. So you see 2021 is the year, month is 4, day is 8, hour is 0, it's midnight, minute is 0, and seconds are 16. This is this 16, and these are some milliseconds probably. Time delta is the duration expressing the difference between two dates. So let's say we have delta is equal to dt dot time delta. Create a time delta of 100 days. So delta is 100. Now date dot today returns the current local date. So let's say we have this one. It's the current local date. We can print it. And today minus delta returns the date 100 days ago. You see, so 100 days ago, it was in December 2020, 29 December. We can compare dates. If today is greater than today minus delta, so the answer is true. Now, the Python programming language objects and map. So this is how we can write a class in Python. We have a class person, and its attributes are department is equal to school of information. It's a variable. We can have a function inside a class which we call methods. Def, set names, self, new name, colon. Self.name is equal to new name. Def, set location, self, new location. Self.location is equal to new location. And we can execute this class. Nothing happens. And then we create objects. So person is equal to person. It's an object. Person.set name, person.set location, and we print. So Christopher Brooks lived in this street and works in the department of this. So this is how we can create classes and objects in Python. We will continue this discussion of classes and objects in the next class. For now, I think this is enough. Thank you very much.